Okay, so we'll start with June 19, paper one. I will, wait just 1 minute, please. Okay, let's start. So as I was saying that we'll try to solve as much as we can in this paper, June 2019 M1. I'm sure that I will not be able to solve this entire paper. So I might need another class to solve this entire paper. Okay, what I'm trying to do is that we'll solve question 2019. Just 1 minute, please. Sorry. Sorry. Really sorry. As I was saying that we will try to solve as much as we can today. And is everyone free tomorrow at 11 a.m.?
Yes.
Okay, for Sharon, it's going to be at 11. Wait, that's 8 a.m. for you, right? Same time in tomorrow because I want to solve this paper within this week. And then in next week, we will start solving 20. Sorry, October 19 is also available. Okay, so October 19 will be our next paper. After I'm done solving two papers within the class, we will start moving to homeworks. For example, question like all the questions from the year 2020 onwards, 2022, 2021, they will be homework, and you guys need to solve and give me your problems in class. I'll solve your problems. And 2023 series, I will solve that paper entirely in class. Okay. That will not be an homework because these are the recent papers. I want to solve those in class in as much detail as I can. So let's start. This is June 2019, M1. In usual cases, M1 has like seven to eight questions. Sometimes if the paper is extremely easy, they might also give you six questions. Okay. But in most of the time, I've seen that they are going to give you like seven to eight questions. The most common number is seven, I would say. So let's just first categorize the questions that you'd actually see from which chapter. For example, this one is from momentum. Okay. So I'll first categorize all the questions and then we'll move on to solving this paper, like solving this entire questions. This one is from momentum. I would suggest categorizing questions is important because then you can already understand that you are only good in some chapters, right? And some chapters is trickier for you. So if you can categorize all your questions, then you try to attempt for the answers which you are quite sure of. So for example, momentum is an easy chapter. This is for connected particles. Connected particles is also easy. So you try to solve these connected particles momentum questions at the very start, or maybe kinematics at the very start. And in some cases, people are usually weak in either moment or in vectors. So I would suggest if you're weak in moment, then you leave the moment question for the last part. Okay, you try to solve your all non questions first, and then move on to the moment at the end. So this is connected particles. Then for part three, this is moment. This is again connected particles, as I've already stated that connected particles is actually the most common topic of your M1. If you can understand connected particles very well, you will always secure your at least grade C is secure just with your connected particles. Question 4, question 5. This is vectors. What is it? This is kinematics. And this is again vectors. The last vector, wait, sorry, I saw a question 3 is also vector maybe. Wait 1 minute. I'll scroll down there again. This is also connected particle pulley theory, right? So I'll just write pulley. And so this paper we have 8 questions, as I've already stated that they will only ask you like 7 to 8 questions. Over here it's 8. So let's move on to the very top. And let's start with momentum. Okay, momentum is a very easy concept, right? Sum of momentum is equals to before collision, after collision. It says that two particles P and Q of masses 3m and 2m. That means mass for P is 3m and mass for Q is 2m. They're moving in a straight line in opposite direction towards each other on a smooth horizontal plane and collide directly. Okay, the speed of P and Q immediately before collisions are 2u and 4u respectively. Again, as a result of the collision, the speed of P is half and its direction of motion is reversed. Now we have only been provided with information for particle P. We do not have anything for the information of particle Q. We have to find out the speed of Q immediately after the collision, but we do not know in which direction Q was also moving. Right? It only stated that P's direction was reversed and P's velocity was halved. As it never said anything about the Q's direction after collision, we are going to assume that it will just start to move in that same direction only. So obviously over here, I'll draw a diagram first. So this one is for before collision, and this part is for after collision. So this is particle P, particle Q. Mass of particle P was 3m, and this was 2m. Originally, before collision, they were moving in opposite directions, right, towards each other. So this was the velocity for P, and this was the velocity for Q. Initial velocity for P was 2u, and this would be 4u. Now, after collision, obviously, you cannot continue to travel towards right, right? Oh no, it can actually continue to travel towards right because P's velocity's direction would also be reversed. So initially, P was moving towards left, and now after collision, its direction would be reversed. So now it would be moving towards right also, and its velocity will be half. Original velocity was 2, so half of that would be u. And for particle q, the velocity is unknown, right? And the direction is also unknown, but I'm assuming that it is actually moving towards left. Okay, it continue to move towards left. And as momentum is a vector quantity, we have to consider the fact that um, one direction is positive and the other would be negative. So I'm considering the direction towards left as positive. Okay, so I'm just going to write left as positive. And now we'll move on to the equation for your conservation of momentum. That sum of momentum before collision is equals to sum of momentum after collision. Now again over here for sum of momentum before collisions, what you have is only this part over here. This particle P's initial velocity would be negative. Other than that, all the values will be positive, right? And another thing, this is just V because we do not know the value for that final velocity of particle Q. So you have this part to this point, you have 3m multiplied with minus 2u plus what is this 2m multiplied with 4u is equals to 3m multiplied with u and plus 2m multiplied with v. If you just make v the subject, but before that on the on the left hand side you have minus 6mu plus 8mu is equals to 3mu plus 2mv. Now over here 6 minus 8 is obviously 2, right? And 2 minus 3 is again going to be minus what? Minus 1. But I'll just write this over here. Like I'll just take everything to the left hand side and just keeping 2mv to the right hand side to make v the subject easily. Yeah, that's 9 minus 8, which is like minus 9 plus 8, which is minus 1 mv. In that case, v is actually minus 1 mv divided, sorry, mu divided by m, sorry, 2m. So in this case, masses gets cancelled out, and now you're left out with negative half u. Okay, half u. So now again, in front of the minus, like in front of this value, you have a minus sign, right? This minus sign actually represents your direction. Now, in the question, they never stated anything about the direction for this particle Q, right? After collision, they never said anything that it continued to move towards left. From our assumption, I thought it would move towards left. But for my calculations, since my assumption is wrong, that's why you're actually getting this negative over here. Getting this negative actually indicates that originally in real life, particle Q never continued to move towards the left hand side. It was actually reversed its direction. After the collision, it has also reversed its direction, just like P. How P has reversed its direction after collision, Q would also reverse its direction. So now it will be moving towards right. That's why your value is negative over here, right? So finally, you can write, even though the question only asks you about speed, right? Speed doesn't have any magnitude. So having a negative over here is not a that much big matter. But if they were specifically asking you about velocity, then you'll have to write that half u meters per second towards right. But as it is just a vector quantity, you can just write so a scalar quantity speed. Now you can just write half u meters per second. You have to just keep that minus part over here because you're working with scalar quantity. Right, so this was the calculations for part A. Is there any problem from both of you? Tashfia, do you have any problem? Okay, Sharon, you?
No questions.
So then we'll be moving on to part B, where part B is about the magnitude of the impulse exerted on Q by P in the collisions. Okay, so basically we are working with on Q, right? Always remember that the information you are going to use depends on where the on is situated. So in this case, since you're trying to find out the impulse on Q, right? Doesn't matter who exerted it, you're actually trying to find out the changing momentum for Q, right? So you're going to use the informations for Q only because it is actually exerted on Q. Q is the particle who is receiving it. For this impulse, Q is the particle whose velocity will change, right? So we're going to use the informations of Q only and not for the one who provided that. Okay, we are only going to use the informations for the object on which this impulse was exerted. Now, before collision, it was moving towards left. After collision, it was moving towards right. Before collision, the velocity was 4v, so 4u, and after collision, the velocity decreased to half u, right? So if I have to explain this again using a small diagram, this is what happens during a collision. They're going to exert a force onto each other, and because of that force, their velocity changes, direction of motion also changes. Right? We're only now focused on the force exerted by P on Q. So this is the force that was exerted by P on Q. So this is Q, and obviously there was a time duration for which these two particles were connected to each other, and this force was exerted on Q. Right? So using time also, time and velocity, you can find impulse, sorry, force and time. You can also find impulse. But problem is, for your question till now, they have not provided you any information for force or time. So we cannot use that equation. We have to use mv minus mu in this part. Again, as I've already stated, direction towards right is positive. So left will remain, so left is positive. So right will remain negative throughout the question. So for part B, you do not need to labelize again the direction towards left as positive for the second part. Okay, I'm just going to use that similar part. For part B, now you have impulse is equals to mv minus mu. V was actually calculated in towards right direction, so V would be negative, right? So 2m multiplied with minus half u minus 2m multiplied with 4u. So now you have minus half into 2 is always negative 1. So minus mu and minus 4, sorry, this is minus 8mu. Finally, you have minus 9mu. Why is it negative over here? Because this impulse was created by exerting a force on Q, right? And that direction of force was towards right. According to our assumption, we took the direction towards left as positive, right? So that's why this impulse is actually coming out to be negative because our direction of force that was exerted on Q was towards right and right was negative according to our assumption. So this much impulse is exerted on Q towards right. Okay, you can keep the negative sign over here, or you can also not write the negative sign. That's totally fine. Or you can also write it down that 9 mu kg meter per second towards right. Instead of keeping the negative sign in front, this is also a better option to indicate the direction. Is there any problem for question one?
Just
Okay, for Sharon, do you have any problem?
no teacher.
Okay, then we'll quickly move on to this question two. This was about connected particles, right? Okay, now it says that a broom is, wait, why does it feel like I have did this? Hmm. Okay, in your book, maybe there was some question like this, right? A broom is being used to sweep a rough horizontal floor. Rough always means that friction is going to be important over here, right? So friction is present. So I'll just highlight this indicates friction is present. And the handle of the broom makes a constant angle of 40 degrees with the horizontal. And as shown in figure 1, the broom head is modeled as a particle of mass 0.5 kg, and the handle of the broom is modeled as a light rod. Light means that the like weight of that rod is not taken into consideration, right? So light means no weight. Now again, after this, the coefficient of friction between the broom head and the floor is 1/4. There is a value for mu is already been provided, 1/4, and the broom head is pushed along the floor in a straight line at a constant speed. Constant speed means that acceleration is zero, right? Rf equals to ma, resultant force equals to ma. That would be zero. There will be no resultant force because acceleration is zero. We need to find out the find out the magnitude of the force that is being applied along the handle of the broom on the broom head. Okay. Now obviously force is being exerted in this direction, right? That is the force that you're going to provide in order to make it move in a straight line at constant velocity. Problem is this force over here is not actually creating like an in outward element, right? As I've already stated in all our vector classes, in all our M1 classes also, that whenever you're working with this kind of cases, always draw horizontal and vertical plane. And another thing to be concerned about is that this force that you're applying that with an angle, this time, this force should always move away from the center. As you can clearly see, this force is actually moving towards the center. So what we do at this point is that I'm going to just extend this force and make it like draw it over here. In that case, we're not changing anything, but I'm just, making it more clear that now it is in the outward direction. It's now moving in away from the center. Originally, it was making 40 degree with the horizontal. So over here also, it is going to create the same 40 degree with the horizontal. So this is force F. You have friction over here. This is friction. Friction is just mu r, right? Force F is going to be F sine 40 degree for the vertical, and then horizontal it would be F cos 40 degree. And for reaction force, sorry, in the vertically downward part, you're also going to be considered about the weight, which is 0.5 g, right? So I'll just erase this. I just write plus 0.5 g. And obviously at top you have reaction force. So now they want you to find out the value of that F which was applied on this broom head. Right, the value of the F can be calculated if you have the value for R. Now R can be calculated if you have the value for F. So you have to use substitution over here. So first let's start to find out the vertical forces. Okay, we are trying to find out the expression for the value for R. So we're going to write resolving vertically. Now again, this entire object is actually at equilibrium. Okay, equilibrium means that it is obviously moving, it is in motion, but all the forces are balanced. There will be no acceleration in any of the plane, not in the vertical, not in the horizontal. So in the vertical plane, we are going to write resulting force equals to zero, and in the upward direction you have R reaction force. In the downward direction you have 0.5 g minus F sine 40 degrees equals to 0. And now you can actually write a value for r using these statements. 0.5 g minus f sine 40 degrees. Okay. Now this is for an expression for r. By using this value of r, you can find the value of friction, which will be required to find the value for your f using the horizontal component. So for friction, you can write friction is actually mu r, right? Mu was 1/4. 1/4 multiplied with 0.5 g minus f sine 40 degree. So if you multiply 0.5 with 0.25, right, what is it? 1/2, 1/4. This is 1/8. So it will be 0.125 g, 0.125 g minus 1/4 f sine 40 degrees. Right, that is the final value for your friction till now. After this, we'll now move on to the horizontal forces resolving part. Resolving horizontally Again, in horizontal motion also, or horizontal plane also, your object was moving with constant speed, so acceleration was zero. In that case, resultant force will be equivalent to zero. Now you have, I'm considering this as positive and this as negative, right? Because obviously, if cos theta would make the broom head move in the forward direction, and friction is a resistive force, so it's always negative. So now you have if cos theta, if cos 40 degree minus 0.125 g minus 1 by 4 if sine 40 degrees equals to 0, or you can write this in simplified format. If cos 40 minus 0.125 g minus minus, you get positive 1 by 4 if sine 40 degrees equals to 0. You're going to keep the if on the left hand side and take that 0.125 to the right hand side. So now you have if cos 40 and then 1 by 4 if sine 40 degrees is equals to 0.125 g. Finally, if you just take f as a subject, like f common from this, is going to end up as cos 40 degrees plus 1 by 4 sine 40 degrees equals to 0.125 g. And that would be cos 40 plus 1 by 4 sine 40 degrees. Can both of you please calculate this and tell me the final value for force? Please continue calculating this. I'm just coming back within a minute, okay? Okay, guys, are you done solving this? What is the answer rate? 1.56. Is the answer same for all of you? Like for both of you then? Wait, wait 1 minute. I actually made a mistake over here. For this part, right, if you're taking all these things to the right hand side, this one should be positive. This one in that case should be positive, and in this case it was positive. Yes, yeah, the answer should be like that. So this one should be negative, negative. This minus, and finally the answer would be like 2 newtons approximately. So this is 2 newtons. Okay. I mean, yeah, for Kashmir also you calculated and you got 1.56, but that was for a wrong purpose, right? I made a mistake during this plus minus calculations over here. Is there any problem for this? What is this question two so far? Tashfia, did you understand? Okay, Tashfia, did you understand the problem I made?
Yeah, I understood.
Then we'll move on to the next question, question three. Question three is about momentum. Obviously, it will involve tilting in all the cases. So let's start with question three. I think we can solve up to question four in today's class, half of the paper, and the other half will be solved in tomorrow's class. Okay, same time, 11 a.m. or 8 a.m. Now, in this case, you have a beam AB of mass 100 G and length 8 meter. The beam is held in equilibrium in a horizontal position by two vertical ropes attached to the beam at points C and D, where AC is zero point 0.5 meters and BD is zero point 0.5 meters. Okay. A gymnast of mass m kg stands on the beam at the point P, and where AP is again 2 meters. As shown in figure 2, the beam remains horizontal and in equilibrium. Equilibrium means that the sum of clockwise movement should be equal to anti-clockwise movement, right? So the tension in the rope attached to the beam at D is 637 Newton. The gymnast is modeled as a particle and the beam is a uniform rod. Uniform rod means that the mass of the beam is now acting from the very center, and the ropes are a light and inextensible string. Light and inextensible string indicates that tension across the entire length of the wire would be same. Right? Tension is not going to change, but the entire length of the rope that is being used to hold this entire beam AB horizontal. So you have to first find out the value of the gymnast, mass of the gymnast, and then the tension of the rope at point C. Now, for your value for the calculations of points of gymnast, right? You still have the unknown value of the tension at C. Tension at C is also unknown. So we are obviously going to consider taking moment from point C so that the tension at C is cancelled and only that M should be taken into consideration, and that will be the only unknown value so far. So let's just draw forces over here. This is TD, which was 637 Newton. Wait, sorry. This is TC, which is unknown. From this person, we have a force downward, which is mg, and exactly from the center, we have this 100 g. Right. So if you're taking moment from point C, in that case, um, gymnast is making the beam move in an clockwise motion. Weight of the beam is also moving it in a clockwise motion. Only tension at D is moving it in a anti-clockwise motion, right? So we can write also the distance between the point C and center of mass, point C and D, is also not known, so we have to calculate that. For example, this distance is actually 2 minus half, it's 1.5 meter, right? The mass of like the distance between C to point P, and then the distance between C to the center of the mass, that is 4 minus like half, 4 minus half, that's going to be 3.5 meter. And finally, between C and D, that will be 7, right? Half minus half, like the entire length was 8. So this half and this half creates 1. So in between them, they have a 7-meter length. Now we can calculate the value for part A. Sum of anti-clockwise moment sum of clockwise moment. In sum of anti-clockwise moment, you had forces like 6p7 multiplied with 7, and in clockwise moment you had m multiplied with 1.5 mg, because m was actually in kg, right? Yes, m was in kg, so it will be mg multiplied with 1.5, adding this with 100g multiplying with 3.5. So finally, you can write this m as 637 multiplied with 7 minus 100g multiplied with 3.5, and finally dividing it with 1.5g. Right, so please calculate this and tell me the value for it. What is the value for that mass of the gymnast? Right, Tashfia, did you also got the same answer?
Yes.
Tashfia?
Yeah, I got 70 as well.
Okay. Then we have to find out the value for the tension in rope at beam at point C, right? Now, since you have already found out all the forces acting on the beam and only unknown was your point C, you can actually use resultant force also in order to calculate this. Because using moment would be a very tricky and lengthy process. You can actually use part for part B. You can use this resultant force part. So you can just use to our next part. The resultant force is zero, right? Object was at equilibrium. Equilibrium means that sum of moment anticlockwise and clockwise should be equal to each other, and resultant force is zero. At the end of the day, all the forces balance each other out. In that case, in the upward forces, you have this TC and TD, and in the downward forces, you have that mass of the velocity and mass of the beam, which was 70g and 100g. Okay. Now for TC, it's going to be 70 plus 100, so 179.8 minus 637. So if you subtract this, you can find out the tension at point C easily without involving moment over here for the second part calculation. So please calculate the value for tension at point C.
1029.
1029. Okay, then 1029 Newton. That is the final answer then. Okay. After this, we will be moving on to that state how you have used the fact that the beam is modeled as a rod. Okay, by our explanation, it means that the beam was, a straight pathway over here. The beam was not tilted, the beam was not rotated at any point. Rod means that there will be no bending along the beam also. So we have considered the fact that it is a rod by using it as the beam remains straight throughout the entire experiment, throughout the entire momentum case. So by modeled as a rod, it means that the beam remains straight, assuming that the beam remains straight. So I'll just write the answer over here, that assuming that the beam remains straight. Now for part C this time, it says the gymnast now gets off the beam and is replaced by two gymnasts. One gymnast of 60 kg stands on the beam at point P, and other gymnast of mass 48 kg stands on the beam at point X. Where AX is unknown to you, the beam remains horizontal and in equilibrium, but then tension in the two ropes are now equal. So TC and TT are now equal, and the two gymnasts are modeled as particles. We need to find out the value for that AX distance. Okay. Now for part C, we are going to draw a separate diagram over here. This is point C. This is point. Sorry, made a mistake. This is point D, this was C, and this was point P. This is center of gravity, right, where your mass was acting from. So 100 G, this was now 60 G, and this was 48 G. This is point A. Tension in C is now equal to tension in D, and this was point B. Now, in this case, obviously, we have to first find out the tension in C is equal to tension D, but after that, I have to also find out that at what from what point I'm going to consider taking the moment from. Since we're only trying to find out the value for that AX, right? So we should take moment from point A. In that case only, we can get the value for your length of AX directly. So if that is the case in this way, then from point A to P, you have this length 2 meter, right? From A to C, you have this length as 0.5 meter. And then from A to the center of gravity, you have this length as 4 meter because it acts from the center, right? This is 4 meter. From A to X, that was X centimeter, which we have to calculate. So from A to X, this is your AX, which is X meter. And finally, from A to D, D is 7.5, right? Because in between CD, the length was 7, and for AC, it was 7.5. So in between A and D, that's going to be 7.5 meters. And we're only concerned about this force, this length over here. Other than that, all the informations are given to you. In order to find out the tension in the two ropes, we have to use the concept of resultant forces. Okay. So we are going to use resultant force equals to 0. The vertical forces are TC and TD. I'm going to consider TC and TD as Y, that is equals to 60G plus 100G plus 48G. This was actually G over here, my mistake. Now TC and TD, they are both Y, so you have 2Y on the left hand side. And on the right hand side, you have 100, 208. G. So in that case, Y is 208 G divided by 2. That means if you simplify it, it's going to be 10 and 4, 104 G. So the tension in each rope is actually 104 G. Using this concept, you can calculate the value for AX by taking moment from point A. So we will now write taking moment from point A, and we'll write the sum of momentum. Sorry, not momentum. Sum of moment. Sum of anti-clockwise moment. Sorry, I'll just write anti-clockwise moment is equals to sum of clockwise moment. Sorry, sum of clockwise moment. Okay. Now over here, the tensions over here in the both the tension, they're actually making the rope move anti-clockwise, and all the other weights are making it move in the clockwise direction. So you can write that 104G multiplied with 2 plus 104G multiplied with 7.5. I won't have much space, so I'll just move to a different page. Okay, now this is equal to 60G multiplied with 2 plus 100G multiplied with 4 plus 48G multiplied with X, right? So if you just have to find out X, in that case you have 104G multiplied with 2 plus 104G multiplied with 7.5 minus 60G multiplied with 2 minus 104G multiplied with 4, and this entire thing will be divided by 48G. 48G. So please try to calculate the value for X from this part. How much is this? This was the continuation for part B, 3B.
All the G's are going to be cancelled, right?
Sorry, I was not here. Can you please repeat?
All the G's are going to be cancelled, right?
Right, all the G's eventually going to be cancelled out. Because everything on the numerator have 1g, so you can take 1g common and that will be cancelled out, divided as this entire fraction was divided by another g.
9.4.
For Sharon, did you also got the same answer? Wait, let me see.
I don't think this is correct because the entire beam is 8 meters.
Oh yeah, 9.4, right. Wait, let me see. This was 2 meters, 100. Yeah, I actually made a mistake. This was supposed to be 100. No, yeah, this was, wait, 100, 104. Now this was supposed to be 100. When I was writing this, I made a mistake. Sorry. This was supposed to be 160 into 2, 100 into 4, and then 48g, right? Then it would remain same. 104 into 2 plus 104 into 7.5 minus 120, right? And then minus 400 divided by 48. This one was 2. Wait 1 minute. Okay, for C, AC distance was 0.5. Right, if AC was 0.5 in that case, AD was 3.5 in that case. Sorry, AD is 7.5. Now that is correct. This was supposed to be 0.5. 104 was 7.5. Yeah, then it should be correct at this point. 0.5. Yeah, then the answer is 6.5. That would be the correct answer. Right, for Sharon, did you also got the same answer?
Yeah, I got 6.5.
Then yes, I can only solve till question 3 today. We can actually not move to question 4. But okay, let's see what question 4 was. Yeah, question 4 is again another part with connected particles. There will be no homework from this paper. Okay, we'll first solve this entire paper totally, and then again I'll solve October 19 also entirely. And after that, 2020, 2021, 2022, those 3 years will be as a homework. Okay, other than that, no homeworks from in between today and tomorrow. Again, we have a class tomorrow at 11 a.m. and 8 a.m. for different timings, and we'll try to solve the rest of the papers within tomorrow. Okay, so yeah, that's it. Also, is it possible to have a class tomorrow from 10 maybe? Because I'm actually available from 10 and I might need like 1 hour, 30 minutes to actually solve the rest of the 5 questions because they're quite big, right? I need to explain them in much detail. So is it possible for Tashfia and Sharon to have a class at 10 a.m., which will be 7 a.m. for Sharon? Sharon, is it possible for you? Thank you then. I'll stop the class over here and we'll start the rest of the paper tomorrow. Okay, should I give this file to you today or after I'm done entirely editing this file, I can send it to you tomorrow after the class? Which one would be better? Okay, I think maybe they're not joining, so we'll start with question four. I think in the last class we completed up to question three. I want to complete this paper within 2 days, so let's start. I don't think we can wait any longer. Right, we were about to like start question four. Other than that, if you guys have any problem from the first three questions, you can ask now. If there is no question, then we'll move on to question four. For both of you, is there any question from for the first three questions?
No, teacher.
Okay, so if there is no question, then we'll start with question four. This is again about connected particles on an inclined plane. The railway truck of mass 500 kg is pushed up a straight track by a railway engine of mass 2000 kg. The train is inclined to the horizontal an angle of theta, where sine theta is 1 by 4, as shown in figure 3. The engine produces a constant driving force of magnitude 3050. The track experiences a constant resistance of motion. Wait, the engine produces a constant driving force. Okay. So this is important. And the track experiences a constant resistance to motion of magnitude 100, and the engine experiences a constant resistance to motion of 200. Okay. The engine and the truck are connected by a coupling, which is modeled as a light rod that is parallel to the track. Light means that the weight of the coupling is not going to be considered, right? The weight is negligible over here. We need to find out the acceleration for the system. Whenever they want to find out the acceleration for a system, you can consider this entire part as a whole. Like you do not need to think of these two objects separately, like truck and engine. You can consider this entire thing as just like an object over here, a particle over here. The particle would have a mass of 2500 kg, right? 2000 plus 500, so 25,000, 2500 kg. So we'll draw a very easy diagram over here. As I always suggest, draw a diagram for this kind of cases. Another problem is your angle was not entirely provided, right? I think the angle was sine theta 1 by 14, so we have to find out the corresponding cos version also, right? But before that, let's just find out the inclined parts over here. This is the perpendicular to the plane, parallel to the plane, and this was your original weight acting vertically downward. Your angle over here was theta, and mass in this case would be 2500 g because you're considering both the truck and engine as one particle. So now you have 2500 g in this part. You have again theta, so the vertical component of weight would be 2500 g cos theta, and this would be 2500 g sine theta. Now I forgot that this was a rough or smooth plane. Wait, incline and angle this. They never stated anything about rough or smooth, right? But they did. Wait, straight track by railway engine of mass this. The track is inclined to horizontal angle as shown. Right. They haven't actually expressed anything about rough and what is this rough or smooth, but they have expressed about the values of resistive forces, right? Maybe resistive forces is a combination for air resistance or friction for this mass. So since you are considering both the truck and an engine as a particle, so their total resistive forces would be 300, right? 200 plus 100. So in the backward direction, you're again going to have 300 Newton. Um, in the upward part, you have the engine force, which was 350, 3050. and in the upward part is it's just reaction force. Yeah. Other than that, there's nothing else. Okay. Now we do not actually need cos theta to solve this acceleration of the system because acceleration only is related for the horizontal motion, not for the vertical motion, right? And for horizontal motion, sine theta is already provided 1/4. So there's no actually point of calculating the um, cos theta over here because we do not need that for the acceleration. So we can actually uh, find part A using this equation of horizontal motions, like resolving horizontally, and then you can write resultant force equals to mass acceleration. Right, for resultant force you have 30/50 in the forward direction minus resistive force is 300 minus 2500 g sine theta is equals to 2500 a. So if you just make a the subject, that will be 30/50 minus 300 minus 2500. 9.8 sine theta was 1/14, right? And this entire thing would be divided by 2500. Can both of you please calculate this and tell me the answer for it? Okay, so what is the answer for part
0.4.
right? 0.4. So we'll write our answer as 0.4 meter per second square. Niloy, you are late, but thank God you arrived at least. We are completing question 4. This was from connected particles, but you can actually focus from question 5, okay? And you have to watch the recordings of the last class and also for this question 4. Okay, this was not part A, this was part 1. For part 2, Tasya, do you have any problem from part 1?
No.
Okay, then we'll move on to part 2, the magnitude of the force exerted on the truck by the coupling. Okay, if I now you have to find out the tension in between, right? Whenever like this kind of situation arrives where your two particles are connected with like are connected via a rod or a string or wire, right? There's always going to be a tension. So they want you to find out the magnitude of the force exerted on the truck by the coupling. Now over here, tension for the engine is actually in this direction because obviously um, the engine wants to move forward, but because of the weight of the truck, there's a backward force that is acting on this coupling, right? So for the tension for that engine portion would be backward. And because of this coupling, the truck is moving forward, right? The truck doesn't have an engine. The truck is being pulled up along the inclined plane. So that means there is a forward force acting on this coupling at the truck end. So for this truck, you have this forward part. Right now, if I have to draw the different force, like force distribution for the truck only for part 2, okay, the entire situation would look a little different. I'm not going to get focused on engine, which is going to get focused on the truck. So this is vertically downward. The weight of the truck was just 2000 G. In that case, this is a vertical plane, this is the horizontal plane, right? In horizontal plane, now there will be a force of tension, right? The tension in the coupling that is being exerted on the truck. There's a reaction force in the vertically downward. It will be 2000 G cos theta. And with the downward force, you have now 2000 G sine theta plus the resistive force on the truck. If I scroll up, the resistive force on the truck was for engine, for truck, sorry, for truck, it was 100. So you can write 100 in the backward direction. That means over here, if you have to find, I mean, the object was accelerating, right? We already found the acceleration for both the particles, that was 0.4. Both of the particles were accelerating at the same rate. So now we can use resolving horizontally. You have resultant force equals to mass acceleration. And now you're going to write that tension minus 100, 2000 g sine theta is equals to 2000 multiplied with 0.4. So that means you just have to make t the subject of this. So it's just going to be 2000 multiplied with 0.4 plus 100 plus 2000. So I think there will be not enough space, so let's write it down. Multiplied with 9.8 multiplied with 1 by 14 because sine theta was 1 by 14. Right, so please calculate this and tell me the value for your tension. Wait just 1 minute. The magnitude of the force exerted on the truck by the coupling. Oh, wait, I didn't actually read the question properly. It says that on the truck by the coupling, Now, the force that I draw over here, this was for on the coupling by the truck. Okay, this was basically force exerted by the truck on the coupling. But couplings actually, they do not bend or anything. So what force this coupling would actually exert on this truck is should be in this direction. Okay, it should be like in the backward direction. The coupling will always provide a backward direction onto the truck so that there's a distance in between the truck and the engine. So the truck and the engine will never collapse, right? For example, a rod. It doesn't matter whatever forward force you're providing, the rod will never be squished, right? So over here, the coupling is acting as a rod. It was stated somewhere in the question. Um, I can't find it now, but it was stated somewhere in the question that the coupling is now behaving as a rod, right, over here is now modeled as a rod. That means it's all going to be squished in between them, so that the force that was present in this rod was in the backward direction, and the engine was providing a forward force of 30-50. Right, so there will be a forward force of 30-50 from the engine of the forward part, and in the backward part there's going to be a coupling of T again. Okay, I'll consider that as a T again. So in that case, there will be little changes. The T will be in the backward part, and there will be forward force from that engine. So 30-50, and then T in the backward. Because if you calculate this, it becomes quite bigger than your overall forward forces, which is not true because tension cannot be bigger than your forward forces. So in that way, this arrangement would change. Now you have 30-50 minus 200 minus 2000 g sine theta minus t is equal to 2000 a, which was 0.4, right? I'll just write 0.4. And now if you have to find out the value for t, that would be just t is equals to 30-50 minus 200 minus 2000 g 114 and minus 2000 into 0.4. So can anyone calculate this? So what is the value of tension over here now?
650.
Right, 650. Okay, then we'll move on to our next math. This was done for question 4, right? We'll move on to question 5. Now, question 5 is a little bit about vectors, so I would expect Kashfi and Niloy to focus more because we haven't explained vectors in our regular classes, right? Now, in vectors, what we actually represent that, for example, in graphs, right? Y-axis is represented as a vertical plane and x-axis is represented as a horizontal plane, right? Now over here, similar condition, y is going to be represented as j and x-axis is going to be represented as I. So you have this vector like two forces F1, F2 that act on a particle, and the resultant of these two forces, that means obviously F1 plus F2, right, is equals to R. And again, it was stated that given that r is in the same direction as the vector this, now remember that r is not parallel to this vector, r is not equal to this vector, it is parallel to this vector. Okay, so we need to find the size of the angle between r and the vector j. Vector j mainly means that you have to find out the angle of inclination between this vector r from the y-axis. Okay, that's what it indicates about vector j. Now remember, they're not equal, but they are parallel. That means whatever the angle r would be creating with the y-axis, this vector 3i minus 2j would also be creating the same angle because they were parallel, right? Same direction means that r is parallel to 3i minus 2j. Okay. Now another thing, how can I actually express 3i minus 2j on a graph? 3i means three axis on the like 3 points on the x-axis and 2 points on a y-axis, but in the negative part because 2 is negative over here. So if I draw this, and this is how your entire part would look like. This is like three axis from the x-axis and -2 from the y-axis. But they wanted to find out the angle between the vector j and your what is it? Vector j and your uh, r, right? Angle it was creating. So they're actually trying to find out this theta. Okay, not this theta because that would be with vector I. They are trying to find out the angle for vector j. Always remember for angle, angle is a scalar quantity, so no need to represent minus plus over here. So now you have 3 and then you have 2 over here, right? And 90 degree in this is this part. So opposite by adjacent. Wait 1 minute. This is they were asking this for vector j, right? Find the size of angle between r and vector j. Oh, for positive vector j, they're trying to find out. We have to focus on this part also. This was not negative vector j. This was for positive vector j. The angle over here that is creating or that is being provided over here from the diagram. This is the angle that your vector is making with a negative j. So you can actually not calculate this. You have to calculate the other way around, but you can calculate this easily. Okay, first calculate this theta, like the angle that your force is making with the negative axis, negative vector j. So we'll just write this as alpha. Okay, so for alpha, that would be tan, right? If I just draw the triangle over here in a much more bigger version, this was 3, this was 2, and this was alpha. So obviously tan we have to use opposite by adjacent. So that would be tan alpha 3 over 2, and in that case tan inverse 3 over 2. That will give you the value for your tan, like alpha over here. But remember, we are not trying to find out the value for alpha. We were trying to find out the value for theta. Angle your force was making with the positive vector j. So it is creating a straight line. So 180 minus alpha would give you the value for theta. So we can just write theta is 180 minus tan inverse 3 by 2. It is 123.69. They haven't given you any decimal places, so we can just write 123.7. This was for part A. Any problem for part A from all of you?
No problem, miss.
Tashvia, is this clear to you?
Yeah.
And Sharon, for you?
Yes.
Okay, for part B, it says that F1 and F2, you can clearly see that F1 has an alphabet I. Sorry, I mean A. I and J are just for directions, right? I means positive x-axis, J means positive y-axis, or negative j-axis, negative y-axis. Now, you have this A alphabet in F1 and B alphabet in F2. And we need to show that 2A plus 3B is equals to 1. We have to derive to this equation at the end. So always remember that if your certain vector is like parallel to other vector, there always has to be a constant over here. For example, I'll just use this expression F equals to MA, where force and acceleration are directly proportional, right? Force and acceleration are parallel, but that will not create an equation. We have to introduce a constant over here. And that's why we introduced a constant in between them. Force and acceleration were parallel, but that will not create an equation. We have to introduce a constant. That's why we introduced F equals to ma, where mass is a constant, right? An object's mass never changes. So over here also, from part A, we already know that your R vector, which was a summation of F1 and F2, is parallel to this 3i minus 2j. So we can now write, whenever we're going to start, like your question is going to start with parallel, you have to create this equation that for R being parallel to 3i minus 2j, you have to write the equation like this: R equals to k multiplied with 3i minus 2j. The k over here stands for your direct, like the relationship. In order to provide an equation, there has to be a constant, so it stands for k. But we do not know the value for k yet, but I think we can find out the value for k, okay? So we can break down R as F1 and F2. F1 was A3 and minus 4. Okay, so AI plus 3J plus minus 4I plus BJ is equals to K3I minus 2J. Always remember arrows in front of this I, J or directions, but don't provide arrows for the alphabets. For example, for A and B, I'm not going to provide arrows, okay? I'm just going to provide arrows for the directions, for the axis indications. Now we can obviously connect that I and A together, I and J together. For example, you have now like A minus 4 I, right? And then 3 plus B J. That is equivalent to 3ki minus 2kj. Now, if you just compare the coefficients of I and j, you're going to end up with the equation like that, which we have to show, which was 2a plus 3b plus 1. Okay, so we can write that comparing I, like if I have to compare the coefficients of I component, I direction, you have a minus 4 plus 3 plus b equals to 3k, right? Hmm.
Miss, why 3
My,
plus B?
oh, sorry, 3 plus b was not k, right? Yeah, sorry, I made a mistake. A minus 4 is equals to 3k. In that case, the value for k actually becomes a minus 4 divided by 3, right? A minus 4 divided by 3, right? This is like an equation 1. If you're going to compare for j, then you have 3 plus b equals to minus 2k. Instead of writing 2, you can input the values of the k into this equation, right? So then we have 3 plus b, or I should just better write it like this. This is equation 2, and I'm going to substitute 1 into 2. So that would be like 3 plus b is equals to minus 2k. Instead of writing 2k, 3 plus b is equals to a minus 4 divided by 3. So obviously this was multiplied with negative 2. This 3 is taken to the left hand side, so it becomes 9 plus 3b, then minus 2a plus 8. So 2a plus 3b plus 9 minus 8, 0. Finally, you have 2a plus 3b plus 1 equals to 0. Right? This was the equation that you have to prove, and we proved it. This was the entire working for part B. Is there anyone having any problems till now? For Tashfia and Sharon, do you guys have any problem?
No problem.
No.
Okay. Then obviously I'm not giving you guys time to write these things because I don't expect you all to write this in class, okay? I'm going to give you this entire file today after the class because it's going to be like completed within today's class. This is kinematics chapter 2. So we'll start. A small ball is projected vertically upward with speed capital U from a point A that is 12 meter above the ground. Okay, just 1 minute. Vertically upward U 12 meters above the horizontal ground. The ball moves freely under gravity until it hits the ground this much seconds later. By modeling the particle ball as a particle, we need to find the value for that initial velocity. Okay, now over here, we have to draw a visual representation for the scenario, right? I would always suggest that draw a scenario and then move on with the maths. Wait, can you just wait 1 minute, please? Right, so as we were saying that this is how the scenario would look like. The vertical height above point A is 12.5, already provided. Right, this is 12.5. So in this part, this is the ball. It reaches to a maximum height and then obviously falls back to the ground, right? Um, so this is U, and the total time of flight over here was 12 by 5 or something, 5 by 7 seconds. Okay, so total time is 5 by 7 seconds. This is a case of double motion, right? We all know in double motion, acceleration overall is going to be negative 9.8. So you're going to write a minus 9.8. And other than that, you have not anything else provided. You have the displacement over here, though. The total displacement over here is going to be the height of the cliff or the point above the ground, which was 12.5. So you can clearly use the equation s equals to ut plus half at square for part A in order to find out the value for u. So we can write for part A s equals to ut plus half at square. That would be 12.5, then 5 by 7 capital U. Half multiplied with negative 9.8 would be 0.5, 9.8. that is 4.9. So it will be negative 4.9 multiplied with t square, which was 5 by 7 square. So 4.9 multiplied with 5 by 7 square actually gives you 2.5. Okay, so I'll just write 2.5 here directly. And in that case, value for you would be 12.5 minus 2.5 over 5 by 7. That's 14. The value for the initial velocity with which the ball was projected in the upward direction is 14. Right, I hope there is no problem on this from all of you. We have done this a lot in physics and in M1 classes so far, right? Moving to part B, after hitting the ground, the ball rebounds vertically and comes to instantaneous rate at point B. Wait, sorry, the time was wrong. I took the time for part B and not for part one. Part one, we're supposed to take the time for 25. Wait, just 1 minute. There will be just few changes. It's going to be 25 and 4.9 multiplied with 25 by 7 whole square. That's going to be 62.5 over here. This is 62.5. So if you change the line, it is going to be positive divided by 25 over 7. So 12.5 plus 62.5 divided by 25 by 7. Yeah, the final answer is actually, wait 1 minute, 25 by 7, 0.5, 9.8, and then 25 by 7 square, 62.5. Okay, another thing that this displacement was actually covered in the downward motion, right? So for your downward motion, your velocity, like your direction is always negative, right? So in that case, this part is actually negative. So now you get like negative 12.5 plus 62.5 divided by 25 by 7. So the answer is actually 14, but the calculations over there was wrong because we used a different time. We used the time for that rebound, but the total time for the first journey was 12, so 25 by 7. Okay, for part B, it says that after hitting the ground, the ball will rebound vertically and comes to instantaneous rest at B point. Obviously, if your object is at instantaneous rest at point B, that means your velocity for point B is 0, and um, this and point B was reached after 5 by 7 seconds. Find the height of B above the ground. Okay, so we just erase these things. I'll extend this line and then draw the extended part. Obviously, I'm going to assume that this is your point A, right? And point B would be lower than that because in collision, some energy is lost, right? During rebound, some energy was lost. So, object can certainly not reach to a higher level like that. So, I'm going to draw like this was a maximum point above A, and this is maybe point B now. At point B, obviously your final velocity is 0, right? Final velocity is 0. The height is unknown. This is, if you can think of it, this is just vertical direction, right? Sorry, not like vertically upward distance. So distance over here should be positive because this is for vertical upward. For vertical upward, object always decelerate, right? Because obviously when it was rebounding from the ground, it has some initial velocity, but along the journey to the maximum point, the velocity becomes 0. So obviously in this direction, object was decelerating. So for deceleration, acceleration would be negative 9.8. Now again, over here, we do not have the velocity for that initial part with which the object rebounds from the ground. We do not have the velocity of this part. So if you want to find out the value for v, and we also have the value for time over here, but not u is provided, we have to use the derivations of the first equation. Instead of writing u, we'll now write v. We'll now use v. So for part B, it's going to be S equals to Vt minus half At square. So V over here was 0. That means this entire part would become 0, right? So now you have minus half A is negative 9.8 and T was 5 by 7 square. This time we're using the correct time. This is SB, okay? So let's write this as SB. This is 2.5. Right, so the height above the ground that was reached was 2.5. That was it for part B. Then we'll move on to part C. It says that sketch a velocity time graph for the motion of the ball from the instant when it was projected from A to the instant when it comes to rest at B. Okay. Now, over here, what usually happens is that with the velocity with which you hit the ground is usually the velocity with which you are going to rebound from the ground. That is the overall assumption, all the cases. Now, it says like this: the velocity with which you're going to hit the ground, that is going to be equal to the velocity with which you're going to rebound from the ground. So this u and v, okay, small u and small v are actually equal to each other. So you can actually calculate the value for small u and v from any of the scenarios, from the first section of the journey or after the rebound section of the journey. Let's just use the first section of the journey. You can use a value for v is equals to u plus 18, which is 14 plus A is 9.8, negative 9.8, multiplied with 5 over 7. So 25 over 7. For the first part, your time was 25 over 7, so I should correct it. 25 over 7. So you get minus 21, right? Obviously, you're getting minus because this velocity was reached in the downward direction and this velocity was reached in the upward direction. So I would just write all these data and then plot a velocity time graph. So initial velocity from like with which the ball was projected at point A was 14, right? Like the value for capital U was 14. Then final velocity for reaching the ground was minus 21. Then again, velocity for rebound, initial velocity for rebound that's going to be positive 21, right? Because this was in the upward direction. And then again, final velocity for rebound. Okay, can you guys just wait for a minute? And the velocity for the like, final velocity for the rebound was at point B, right? I'm talking about point B. At point B, it was 0. So if I have to plot a graph, always remember that they were all accelerating at the same rate, which was 9.81. So every section of your graph should be parallel to each other because they're all accelerating at the same rate. And since this is a velocity time graph, this will be a velocity time graph or vector quantity time graph, right? For vector quantity time graphs, you are going to draw sections of your graph above and after the graph. Another thing, the distance traveled during the first before the rebound is like this, that over here whatever distance was traveled from the point of release to the maximum point was also covered in this part, right? So overall the total distance traveled over here is just 12.5, right? So in that case, the first line that should be drawn over here from 14 to 21 Right, so I'm going to think this is 14. So this is like 21. Right? Wait, this is not a straight line. The graph should be an entirely straight line. This is 14, this is 21. And I'm just going to copy it. And I can draw a vertical line. 1, 2, 3, 4, 4.5. 1, 2, 3, 4. So your other line should exactly start from that 21 in the positive plane, right? But it will stop at 0. I'll just delete that original line. I just wanted to make sure that this line is parallel with this line because they were all parallel to each other, right? And again, in between them, this blue line will never be apart, but I'll just, connect these blue lines with this broken lines and then remove the blue line from this part. Okay. Not possible to remove it. Wait 1 minute. This is how the graph would look. This is 14, this is 21, and this is minus 21. And obviously the lines are parallel to each other because constant acceleration. Like I mean constant deceleration, right? Because both of the lines are downward sloping. So constant deceleration of negative 9.81. I mean just 9.81 would be right because we have stated deceleration over here, right? So this is how the graph would look like for part C. Obviously V in meters per second and time in seconds. This was your point A, right? And this was your point B. If you have to write this also on your graph, you can. And again, time taken for this journey was 25/7. The time taken for this journey was 25/7 plus 5/7, right? So 25/7 plus 5/7. That is going to be 30/7 over here. Like, is there any problem with part C? Okay, then we'll move on to question 7. How much time do we have? Okay, we can solve question 7 today. Okay, and maybe question 8 also. Let's start first. In this question, this is again about vectors, but this is quite trickier than the previous vector. Okay, it says that in this question, I and j are horizontal and vectors. Are horizontal unit vectors and due east and due north respectively. That means I towards the east, which is x-axis, and j towards the north, which is y-axis, right? And position vectors are given relative to a fixed origin O. Always remember when you're working with vectors, right? You always measure a distance, okay, from a fixed origin point O. That is what they're stating at the very start. Now, in this question, it says a ship A is moving with constant velocity this, and at 2 p.m. the position vector of the ship is 8i minus plus 7j. And there's another ship which is moving with a constant velocity of this. At 2 p.m. the position vector of ship B is also given. So we need to show that after t hours, BA is like this. BA means that after 2 hours, obviously they will not be at the same point, right? They will continue to move away from that position they were originally at. And after 3 hours, how much distance they're going to be away from each other, that can be represented in this format. Okay, so before that we understand, let's just find out that what exactly happens within the time t hours, for separately for A and separately for B. I'll just use this page. For example, as we have already stated that these distances were always taken with respect to the origin O. That means originally at 2 p.m., Your ship A was at a vector of 8I plus 7j, right? So that means I'm just going to, draw it like on a very actual graphical way because I want to explain this clearly. But after some time, after doing few maths, you'd understand that this graphical representation is not that much required also. This is your origin, right? On a graph paper, this would be your origin. Originally, your point A was 8I plus 7j. So 8I, wait 1 minute, 8I plus 7j and 1 plus 2. So I'll just write 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7. This was your position for ship A at 2 p.m. and for ship B, it was at this point, I plus 2j. So if I have to find out the vector, how can I find out? This is how I connect the lines, right? This is for the line representation for ship A and this is for ship B. Now, problem is they will not stay in this case forever, right? They will obviously move away from this position. For example, maybe your after t seconds, after t hours, right? Ship A is not over here anymore. Now ship A is in this part. Okay. Now ship A has changed its position, and now ship A is going to be at this part. And again, ship B is not going to remain at this position. Ship B might move and go to this part. You now have to find out the value of this BA from B to A. Like how much distance ship A is from B. Like this length should be found out. But for this length, we have to find out this length also, right? Like after t seconds, where do they actually move, right, from origin? So you can find this out by creating triangles over here. For example, this was the triangle for B in order to find out that what would be the position of ship B after t seconds. And again, you can find find the position for A also, that what would be the position for A after t seconds. Okay, so I'll just copy this diagram and explain this to you again in much detail. We have to actually extract three triangles over here. The first triangle is from origin. This was the original position of B. This is the B prime, like new position of B after t seconds. This was the original position of O, A, and this was A prime. And we need to find out the vector from B prime to A prime. But before that, in order to find out that, we are actually provided with data like this. We can actually use this like time and velocity and distance to find this B to B prime distance, A to A prime distance. And then use your O-level vectors to find out the length of OB prime and OB A prime. So let's just focus on the triangle for A first, okay? So we're just going to focus on this triangle at first. I know it might look very messy or complicated, but it will be easier when we are going to solve this maths. This is O. Now always remember the position vector. Position vector is basically the distance with respect to the origin that was provided was this, right? 8I plus 7A. So this is OA, which is 8I plus 7J. For Tashvia and Niloy, if you guys have any question, please interrupt and ask me. I won't mind. Okay, and from A to A prime, think of it like this, that you already have a displacement, right? In order to find a further displacement, you just have to find out what? Velocity into time. That would give you the value for your displacement, right? In order to find out this part, your working should be original displacement plus velocity into time. It is always this case. So from A to A prime, or I should write this like this, that A prime with this vector. This line over here actually indicates the direction in which we are traveling. For example, from O to A, the direction is OA, right? From A to A prime, the direction is A prime. So in that case, I can break this down as OA, position vector of OA plus VT. It was moving with constant velocity, so the velocity will not change. And time was t seconds, right? It was stated over here that it was moving with constant velocity. So you have 8I plus 7J plus 2I minus 14J multiplied with time, because time was not given, time was just t for it. So it's going to be 2I minus 14J multiplied with t. Now obviously I have to simplify it. It will be 8I plus 7J plus 2IT minus 14JT. So obviously we're going to write the I together and J's together. So you have 8 plus 2T I and then 7 minus 14T J. Now, up to this, we could have only calculated the value for a to a prime. We still have to find out the value for o to a prime, right? Now we are going to use the vector part. That whenever your vector is creating a triangle, right? Think of it like this: from O to A to A prime. They're traveling in the same direction. How can you understand if they're traveling in the same direction? That is, look at my arrow. I can connect this line without lifting my arrow. But when I have to connect this OA prime, I have to lift my arrow and then move to the origin again, right? So in that case, OA and AA prime are in the same direction, but O and A prime is in the opposite direction. Whenever the case is like this, that two lines in a similar direction and one line in the opposite direction, we're going to create an equation that OA prime will be in the opposite side of your equation, and that would be equal to OA plus AA prime. Right, this is how we're going to create the vector. I hope all of you remember from this your like IGCSE Maths P, right? So OA prime and OA was what OA was already given to you, right? OA was I mean, after this, actually, you don't need to find out this length later on, because for this part, actually, A prime is only this position. Like I actually made a mistake. This A prime should only be this part. Right? I'll just reuse this part. Just position it over here. For A prime, we should have just used equations of Vt. Okay, velocity into time. That would give you the positions like the distance traveled from O to A prime, from A to A prime, and that would be just this 2I and 14G. And if you add this together, OA and A prime, that will give you the value for OA prime. Right. Is there anyone having any doubts for this part A? Just we found out the length of this, OA prime. Any question till now?
Are we using distance equals to velocity into time to calculate A and A prime?
Sorry? Why do we need A and A prime? Was this the question?
No, like, are we using the equation distance equals to speed into time to
Right.
calculate?
Yes, we are using the equation distance equal to speed into time because it was stated that your object was moving with constant velocity, right? So we can use that equation only. Okay, then we are again going to move to for part B calculation. For part B, we have to focus on just this black portion of the graph in order to find out OB prime, right? This time. Okay, so for OB prime, OB is already provided. I plus 2j that was. Yeah, right. I plus 2j and velocity this time is 12I minus 4j. So for B and B prime, like this is already I plus 2j, right, from O to B, and from B to B prime, this is going to be B to B prime VT, which is 12I, I think it was minus 4j. Yeah, minus 4j. multiplied with time. So that would be like 12ti minus 4tj, right, b to b prime. And then we can find out the value for OB prime, which we can clearly understand. It will be in the opposite direction to that of OB and B prime. So we can write OB prime is equals to OB plus B to B prime. Obviously, arrows are important over here. Now, OB and B prime can only be calculated by adding this I plus 2j and then 12ti minus 4tj. Finally, for B to A, they were trying to find out the length of B to A, which means now you have to find out this. From this portion, we're just going to focus on this triangle. Right, this is O. OB prime was what? I plus 12 of t and 2 minus 4t. This was for OB. It was, I can write it down over here. OB prime was I plus 12ti and 2j minus 4tj. I'll also write down the value for your OA, which was this. I'll use this length actually. Okay. In order to find out BA, remember you want to find out BA, not AB. In that case, OB and BA are in the same direction and OE is now is in the opposite direction. So you can write this as OA is equals to OB plus BA, like B prime to A prime. Remember that you have to find out B to A, right? So you have to just make this the subject of the equations by moving this OB to the left hand side. So the entire equation will look like BA is equals to OA minus OB. Now, I'm obviously explaining this vectors maths from the very basic, so I'm extending it very long, right? For example, you don't actually need to do this calculation. After a few practices, you can actually move on to this directly. Do not make much lengthy this maths. And then after this, OA was like this time this is actually O prime B prime, right? OA prime B prime. So OA over here was 8i plus 7j plus 2ti minus 14tj, and this will be entirely subtracted from this. So I over here is going to be negative 12ti minus 2j and plus 4tj. So we're going to add the i's together and j's together. So you have 8 and 1 minus 1. So it's going to be 7i, 2t and minus 12t. So it's going to be like minus 10t I, and then 7j and 2j minus 2j, that's going to be 5j. Let me just correct, like cancel it. We have used all these things. Sorry. It's 8i and I, right? We have used this 2t I and 12ti. I've used it 7j and 2j. We are left out with 14 and 4. So that's going to be like minus 10tj. 10tj. Okay, so I can take I common now. So that's going to be 7 minus 10 t I plus 5 minus 10 t j. Okay, so this was your vector VA that they were asking to find out. For this part, we have to do like what? 3 more parts, right? Is there any problem so far for this entire maths? For vectors also, I would suggest drawing these triangles beside for every section. It's just easier for you and the examiner to check. And even if you cannot, like draw this entire or like, complete the entire map because of lack of time, drawing these triangles beside will also give you like some marks. Not total mark, but you'll at least get something other than zero. Okay, any
Okay.
problems?
Question is about it's a 2 kilometers from each other. এখানে
Two
উঠে
kilometers, না বাবা, 2 kilometers ছিল না. It was that the entire journey started at 2 p.m., right?
বিতে এখানে
The
বলা
time.
আছে না hence find the length of time for which the ships are within 2 kilometers from each other.
Oh, that was for part B. We haven't actually reached that. It was just for part A. Right, we just completed this. Okay, we still have a 7 mark question left for part B. Okay, now it says that hence find the length of time for which the ships are within 2 kilometers of each other. Now they have already stated that your displacement for that BA is already 2 like what is this 2 kilometer, right? We need to find out the time that at which point they're going to be like 2 kilometers from each other. Now remember that over here, this is a value for your displacement, right? Like a vector, this part obviously represents the distance from B to A is a representation for displacement. Now in O levels, how would you actually find out the modulus of a vector? By squaring the coefficients of I and squaring the coefficients of J, right? Now this is a vector version of displacement in order to find its magnitude only. For example, in that part, when it says that the distance of B to A is 2 kilometers, they're just giving you the magnitude. They haven't provided you with the directions. But in this part, they actually have provided you with directions like I and J. But problem is you now do not need the value for directions. You just want to find out the value for your time. So you can find the value for your time as like this. We have to first find out the magnitude version of this vector. Okay. So magnitude of from my maths, it's actually A prime, B prime. That would be the modulus of BA. Okay, always remember modulus works with absolute values. Anything in between becomes zero. We're not going to take that into our calculation. So modulus of BA was already given to you, 2, but we actually write it like this. 7 minus 10t whole square plus 5 minus 10t whole square, everything under a root, and we're going to take this 2 on the other hand side. Obviously, we're going to take this root to the right hand side and make that 2 square. And if you break this down, you have 49. 14 plus, so 70 is 2 into 7 into minus 10. You have minus 140t and plus 100t square. And then again 25. 5 into 10 into 2 is 100 minus 100t, and then again 100t square is equals to 4, right? 2 square becomes 4. So now you have 100 plus 100 is 200 t square. Minus 140 minus 100 is minus 240 t, and then you have like these values are already been used. Now you have 49 plus 25, and if you take this 4 to the left hand side, it becomes negative. So 49 plus 25 minus 4 is 70. You're not supposed to cut this from your main paper, okay? I just cut this for my simplicity. From this part, I can actually take 10 common, right? And that would be like 20t square. 24t plus 7 equals to 0. From this position, I can use middle term. I'm not obviously doing a middle term over here, but on your exam paper, you should do the middle term, okay? I'm skipping that middle term part. I'm using the calculator to find the value for t. So the first value for t is 7 by 10. Remember that this entire thing started at 2 p.m., right? So the second value is again half. So there are two possible values. Wait, right? Oh, it says that find the length of time for which the ships are in, like within 2 kilometers of each other. So it's starting like this that from this time one, they started to be within 2 kilometers, and then again after like certain periods of time, at time equals to half hour, they again become 2 kilometers within each other. So we just have to find out the difference between these two values. So which is going to be time is basically 7 by 10 minus 1 by 2, which is 7 by 10, sorry, 7 by 10 minus 1 by 2. So you have 0.5 hour. For 0.5, so 0.2 hour, my mistake. 0.2 hour. Now, you can express this as an hour or better would be in minutes. Do you guys know how to convert this into minutes? For example, if you're using the black calculator, there's a sign like ENG and there's a button before that or above that. Before like above the button ENG, you have this part. You have this button. This actually expresses any decimals into hour, minute, and seconds. For example, if you just write 0.2 and press equals to and then again press that this button, you'd see that on your calculator it shows that 0 degree 12 dot 0 dot dot. This is like hour, minute. This is seconds, which means that 0.2 hour is actually 12 minutes. Is everyone able to find this on your calculator? It is above
Yes.
the ENG sign, right? Above 8 almost. Niloy? Okay. Sharon, did you also found this? Okay, now I'm not actually in the state to solve question 8. But okay, still just we'll just complete question 8 within today. I don't know why they put 7 marks for part B. It was not that much lengthy, right? I think the marks should be like reversed. For part A, it was quite lengthy and they were giving you like only 5 marks. But for part B, they were giving you 7 marks. Or maybe the total mark for this was 7. Wait. The total mark is given at the very end. Oh no, they are actually giving you 7 marks for just this working. Okay, they're good for us, right? I mean, you're just getting 7 marks for very easy working. Yeah, that's it then. We are done with question 7. I hope it was clear. If you guys have any questions, please ask before we move to question 8. Okay, then I hope that there is no question. We will move on to question 8. The question is about pulleys and of connected particles, right? I believe we did this in our regular classes. This was actually included in your worksheets. So, not that much stuff. And again, Tashvi and Niloy, you guys were supposed to sit for an exam, but you guys didn't. So, are you guys free today after the class to sit for an exam? Maybe after half an hour also. You take a half an hour break and then sit for an exam. Why? Do you have any classes after this? Nanila, you cannot blame Ramadan for it that just because of I'm fasting, I cannot sit for an exam. We're all fasting and we still have to sit for an exam, right? There's no other options. Uh, oh, okay, sorry then. Niloy, sorry, Ashvia, do you have any problem if you're going to sit for an exam at 1 p.m. today?
Okay.
Okay, Sharon, if you are free, like within an hour after this class, you can also sit for the exam on connected particles. Okay, Niloy, then there's no option for you. You have to sit for the exam at 1 p.m. Okay, then we'll start with question 8. The particles P, Q, and R have masses 4m, 3m, 2m respectively, where we can clearly see that Q and R were like connected particles, like exactly connected to each other without any strings, and QR is connected to P with a string over here that is coming over a pulley. And particles P and Q are connected by a light and extensible string that passes over a smooth light fixed pulley. Obviously, this one's from the very first chapters, we actually haven't explained chapter 1, but as we have stated that chapter 1 is not that much tricky part because this section, smooth, light, fixed pulley, it means that smooth means that there is no friction over here, and light means the pulley's weight is not going to be taken into our consideration for our maths. Okay. Light in extensible string. The particle R is attached to Q. The system is held in rest with the string taut and lightly hanging parts of the string vertical. As shown in figure 4, the system is released from rest. Find the acceleration of particle P. Okay, in order to find out the acceleration of particle P, we have to understand that this part is like 5m and this part is 4m, right? So you can clearly understand that there is a greater force on the QR side than in the PR, than on the P side, right? So obviously when we're going to like release the system from rest, QR will move downward and PQ will move forward or move upward, right? They will move downward with a certain amount of acceleration and they will move upward with a certain amount of acceleration. So we just have to write an expression for t also, and then the t will actually be cancelled out. For example, if I have to draw the force distribution, I'm going to consider this QR as a whole, which is considered as a 5 mg. M is mass, right? Yeah. So 5 mg in the downward direction, you have tension in the upward direction. And over here, you have 4 mg in the downward direction and tension in the upward direction. For particle P and Q combined, okay? So Q and R combined, Q and R, a 5 mg is a greater force, so we can write 5 mg minus tension equals to 5 ma. And for particle Q, object was moving in the upward direction, so tension is greater this time. So T minus 4 mg is equals to 4 ma. The tensions get cancelled with each other. We have 4m minus 5m, that's just mg, is equals to 9ma. Finally, you can clearly understand the masses would be cancelled out. For the value for A, it's just going to be 1 over 9g. 1 over 9, sorry, 9g. I should write the g like this, so just not confusion with the 9. Right, so this is a value for your acceleration. Is this clear?
Yes.
Okay, and then again, we have to find out the value for tension also, right? So for tension, we just have to, can you just wait for a while, please? Very sorry. Please wait. Guys, there's actually an emergency and we cannot solve question 8 today, okay? So I will solve question 8 later and send you the video as a compiled. Okay, really sorry for this. I'll explain this question 8 later, okay? So I'll stop the class over here.